Alright, today what we're going to do is we're going to experiment with a thing called Wheatstone Bridge. A Wheatstone Bridge is 4 resistors, with 3 resistors that are known, and 1 unknown resistor. And then what you do is you change the resistances. You can either take what you measure, or try to measure up the resistance until it gets to a certain point where you got 0 volts between the 2 points in the middle. As you'll see as we experiment with it. Last time you saw me make the 4-wave bridge rectifier. It's kind of like that, except it doesn't use diodes, it uses resistors instead. There's 4 resistors that are like in the bridge way, like the diode bridges. Anyway, what you'll need is 4 light bulbs, incandescent ones. Come in. Do I have the package still? Here they are. Something like these. They're the cheapest ones you can get at Walmart for it, and then you can get the other. You have to have 4 of them. And do experiment to see how well it works. I recommend getting 2 of these, 2 different wattages. This is 25 watt. I think the other one was like 40 watts. Get both 25 watt, 40 watts, 4 of each. Now, here's another thing I want to tell you about the socket. My money couldn't have enough money to get the socket that comes on. That comes on the cord where you put wires in between the screws and you put it that way. I decided to do this instead, and it worked out pretty well, better than I thought it would.
Hey, can I have your receipt? I gotta log it in.
Okay. Right there.
Thank you very much.
This here is a outlet to light bulb socket. If we take the 2 prongs, we solder to them, which I just did. The solder stick to it pretty well. I thought I was gonna have problems with it because I thought it might have been brass or something to turn the solder to. But anyway, it stick to it. I don't know if it's brass or not. It probably is, but it was made enough that the solder would stick to it. Solder can stick to it pretty well. It's better than I thought it was. Because that was probably going to be the whole. I thought that was going to be the whole problem. The whole big booger. The thing was getting wire soldered to those pins, those prongs on the adapter. Yes, I could have gotten like 2 outlets. Bought 2 wall outlets and then put on. I have like 2 in 1. Then bought 2 of them, give me 4, then break the tab off in between 2 of them. Make those where the positive and negative will line the neutral will go to. But anyway, we're gonna get a later on. I'm gonna go back and get the light bulbs, and also gonna get a socket to outlet adapter, so I can measure what the current is, so I can balance the current and see if it certain stuff that draws from electricity from the outlet, to see what they draw with an AC voltmeter. Because basically Wheatstone bridges, they don't measure current, they measure voltage. And you can say that the current is measured by a voltage. Very safe to do it this way here, because the thing is, if you the other way around, you have to deal with high power resistors and stuff like that, and deal with wattages and stuff, that you get expensive stuff. This is probably actually the cheapest way to go, measuring AC current with an AC voltmeter. Anyway, let's go over the schematic. Okay, here it is, our circuit we're going to use. There's 4 light bulbs that you see there. LA1, LA2, LA3, then the one with the software is LA4. Now, if we know all the rest of these light bulbs with the wattages, we get a resistance from them by using Ohm's law, and we should be able to figure out what L4 is, LA4 is, with whatever the resistance is of all the rest of them by solving for it. We'll go over the formula pretty soon after we get done testing with it. And if they're balanced, then you would have 0 volts coming out between them, where your voltmeter be measuring from. 0 volts. Because we'll be measuring between these 2 voltage dividers. As you can see, that's what it's like, a voltage divider, where it's 2 resistors in series. In the middle is your output. You can see if 2 of them make a bridge with it. That makes it where it'll have a voltage difference between them 2. As you'll see in the equation, you'll see how it works later on. Okay, I have the Wheatstone Bridge in my hand here. Here it is. You can see the sockets. Do write on it. I tried writing on there, then I messed up, so I decided to do it on the cardboard. There's R1 is right here. R2 is down here. R1's here. R2's down there. R3 is right here. And R4 is right here. And these are 40 watt, 25 watt light bulbs. All of them. It uses the ones you plug in the socket. While you put in the socket and then you plug it into the wall, but instead of the wall, put wires on them. And it will actually soldered pretty well, as you saw. Anyway, let's take a look at how it's going to work. Okay, I got the meter over here. It's on volts AC and it's under the 200 volt range. Since we'll be expecting something between 0 and 120 volts. We got all 4 light bulbs in connected up to it, and all 25 watts. It's not plugged in yet. As you can see, the cord is right here. You have to plug them in carefully without moving them and having the leads touch each other. And then right over here we got these here. I forgot to tell you, these are the 2 wires that go from the middle of between each light bulb. They go to the meter to measure it. What we expect that's balanced. It should be 0 volts. So close to 0 volts on the meter. Checking something for a minute. Okay, good. Plugged it in. You see the lit up over there. You're only getting volt 0.5, which is that means it's probably balanced. Of course, it's off by tolerance and heat, and also the voltage. And stuff like that, but if it's close to 0, which one is, because that's 120 volts going into it, and That's a lot. That's a big voltage drop. So I say divide out pretty well. It's pretty almost exactly the same if it's subtracted by each other. You get 1. As you'll see in the formula, it's coming up soon in this video. Let's try out adding a 60-watt bulb to R3 and see what we get. Actually, R4, I mean. Okay, we got R4 over there, which is this bulb right here. It's 60 watts. West of them, 25 watts. We should see a difference. It's definitely not balanced. We should see some voltage there, a lot more than 1 volt. Here we go. And this is brighter since it has less resistance in its way. And look, you can see over here, 43.5. You can see this bulb is brighter than the other 2 over here. If you can, I don't think you can tell because it's so bright you can't even see the other bulbs. But it's brighter than the other 2. That's because the 60 watt is bigger than 25 watt. It's a bigger wattage. So it has less resistance in its way than it was the 25 watts. Now let's go with some of the math behind it. Okay, here's the math behind it. As you see, it looks like the voltage divider formula, except it subtracts 2 ratios in it, or fractions, in the form of the voltage divider way. And right here, it shows you that it's balanced if they're both fractions are the same, equal to each other. Now we're gonna do this graphing calculator over here. Is we're gonna graph Y1, which is the Wheatstone Bridge formula, and then Y2 is your Ohm's law. As you see, 120 over X, which could be your resistance, the unknown resistance. We're gonna see if it's linear or not. Let's take a look. What do you know? One of them's non-linear, and the other one is. Which one is it? It's the Wheatstone Bridge one is linear. Because you can see the line going across like a linear function. Then Ohm's law is that one, the other one. Yeah, it's not linear, because the little pencil could go through it. From up and down. Does it pass the vertical or whatever, which line test you do it with? And that's basically, that means it's pretty easy. So you just plug in some resistors in and you can figure it out. It might matter, might make a lot, it makes sense if you use the correct value resistors that are not too low or not too high, that are just perfect. That make it so that your meter can read the voltage on it, so that to drop it way too low. Well, that's it for now. I hope you enjoyed this video. Next time, what we're gonna do is I'm gonna try to get some capacitors. I'm gonna try. Actually, I might try to do this first. Is get some. Get a bulb, and so I can try different ratios, see the different ratios with the different 2 sets of bulbs, different, but the ratios are the same. See if it will still even out easily. And that. But that'll be next time when I go back to the store and I got enough money. Well, that's it for now. I hope you enjoyed this video. Don't forget to check out my store. Shop YouTube, coupon code YouTube 2018 for a 4% discount. Well, that's it for now. Thanks for watching. If you like it, and subscribe.